Good morning, everyone, and welcome to the presentation presented by PS0. And our presenter is Mr. Gerald Rigstad. He will be presenting on PS0 pore strips, and it's up your floor. Thank you.
Okay, thank you, Carol. As Carol said, my name is Jared Rigstad. I am a vice president with PS0. And if we presented a few times, Sunday, Monday, now Tuesday, and this presentation is a little more engineering focused. My dad, brother, myself, we have a structural engineering firm, over 40 years old. We're structural engineers, do what you all do, and we developed this product from that company. And we wrote an article back in June of last year on construction productivity around pore strips. So I'm going to be focusing a little bit more on that and the details of, restraint a little bit and shrinkage, but we only got a half hour. So I've been traveling around quite a bit doing lunch and learns, PDH lunch and learns on this topic. So if you're interested in that, please reach out. Please utilize the chat function if you like, if you have questions that come up. I know it's a very quick presentation, but I can get back to you, or I might have some time at the end, but I just want to get through our material and really show you what we're talking about here. So I am going to share my screen and let's see here, make sure that I am sharing the right things. Let's see, presentation up. All right, so yes, so engineers out there, have you ever had the question, from the contractors? We all get it. Why do we need pore strips? Can we remove them? Can we close them up sooner? It's a constant question we get on every pore strip job we have. And so this is the article, the issue of CI, ACI's magazine. If you're not familiar, the CI International, Concrete International is ACI's major publication monthly. And we wrote this article and it focused on productivity around pore strips. The main issue, location matters, and talking about the different products out on the market, mechanical couplers and lockable dowels. So, and we really are talking to focus in the engineers, because how the engineers design their pore strips and where they put them really dictates how the contractor has to build, the structure. And it's not just a means and methods issue. So what's a pore strip? We all know this, that it's, two separate slabs with the strip in between, left open, 4 to 8 feet wide, 120, 28 days. I mean, the longer you leave this open, the better performance of your slab you're going to have. So, but the longer you leave it open, the more the cost goes into the project, but at the end of the day, when it's poured back, it's just the ACI rebar lap splice, a code permitted lap splice. And pore strips are used in PT, post-tension concrete, and RC, reinforced concrete. So you see them in all kinds of concrete that has volume change. So here they are. When they're poured back later, they provide shear transfer, moment transfer. There's no PT that goes through there that is stressed. So this strip is a reinforced concrete strip, but it allows the engineer to have all their continuity like they normally would in a slab. It's just a reinforced piece. So you're transferring all your diaphragm loads, all your moment, your bending, your shear, everything. But the problem with the pore strip is it's on the critical path. The concrete frame is on the critical path of every job, and the pore strip is on the critical path of that, because no other trades will work across that pore strip. So you often see stuff starting and stopping at the pore strip. And then all those trades have to come back to finish their work once it's poured in. You can see here, this pore strip couldn't even be, the formwork couldn't even stay in place because they needed to have a pump come down from the levels above and then reform every level. So you can see how much cost goes into, pore strips and delays. And it's a safety hazard, and you're having an open gap in your structure. So, general contractors, safety is paramount on a job. And the most expensive concrete, it is the most expensive concrete your concrete contractor will pour on the job. So the main issue, we need them because of volume change. Every concrete has volume change. It does. And we're not going to get away from that, especially with PT, because PT has additional elastic shortening beyond shrinkage and temperature volume change and creep over time. But all this is fine if we didn't have restraint. So PTI is publishing a new restraint article that's coming out soon. It's just on a committee days, so that's coming out, so look for that. But restraint is something that's not very well understood and not something that our computer programs do well for us, okay, as helping us identify the stiffness and strengths. Everything in your structure has restraint, even columns, you know, that aren't part of your lateral system. So here from ACI 309, we have some calculations, pretty simple calculations, just a reinforced concrete slab, 100-foot long, free to move. You know, humidity 75%. I put this temperature down here at 70 degrees because sometimes you can get these big swings. And on the right-hand side, you see with and without temperature. So temperature can have quite a bit of impact on your structure. And in the colder climates, when you're doing work in the wintertime, the contractors will pull all that heat after a couple of days when the concrete reaches 2,000 or 3,000 PSI. The problem is that concrete that had the heat pulled from it will still undergo the temperature change. So temperature change has a big impact on your structure. I know a lot of engineers who want the building envelope up first prior to filling in the pore strip. So that's interesting. So here we have a PT slab. And as you see, we just are adding the additional shortening due to elastic shortening and the shrink shortening, the creep shortening. So that's all here, long-term and short-term. So, and this graph, I love showing it to engineers because not everybody understands where these numbers come from. But here you go, 28 days, you have 40% of your volume change out. At 120, you have 70% out. So this is, you know, directly related to your slab performance. The problem is, as we leave it open longer, we get better slab performance, but the cost of the project goes much higher as well because of that. Restraint. Things are complicated these days. We don't have a lot of simple buildings. You know, our architectural friends are doing things which is cool. They're cool things, but we need to be aware of, you know, all the restraint and issues and how we're pulling PT and when we need pore strips, when we don't, when we need them for, you know, all the case. There's a lot going into all these projects. So location, the engineer defines this location between columns. They're going to put these pore strips at certain places in the building that are going to allow for sometimes stressing or length of poles or just length of structures or separating stiff elements. That's a big one. And you're going to put it at a fifth span, which is like some people say quarter span or third span or things like that, but it's actually 0.212. Okay, so it's really close to 0.2, which is a fifth span between columns. At this location, shear is high, moment demand is very low, 0 is an inflection point. Otherwise, you're going to put it at a mid-span location. Mid-span, that's where your moment demand is high, but your shear is low. But there's certain aspects of both of these that are advantageous for engineering, for building, and we'll talk about those a little bit here. So I want everybody to understand ACI 347. My older brother sits on this committee, and this reshores and backshores, not all engineers understand these. Basically, if your slab cannot be self-supported, you need backshores. Backshores that need to be left in place and load accumulates down your building, which is a huge thing because the backshores get a lot, and you know, there's a lot more backshoring and shoring needed at those lower levels because the load is accumulating down the building. So here, a fifth span between columns, inflection point right there. All right, engineers love this because there's not a lot going on. There's no bending going on here, okay? But there's just shear. So it's super simple. And your PT, if this is PT, your PT is already in the middle and makes it easy. Your design's easy. And we actually think that with our system, this location is the best for economical for the whole job because this forces contractors to have backshoring on the long span. They have to have backshoring to support that longer span and support the loads above. So this right here always has to have backshoring. This short span doesn't need it. So you see this often in reinforced concrete. In PT, you see it as well, but you also see a different location in PT because when it comes to PT, you can do something a little different to get away from backshoring. So again, backshoring. Your load accumulates down the building as you see this. So these red shores, everything is accumulating and you're going to need more shoring as you work your way down the building. And this is going to be huge for the contractor, the general trying to have his other trades finish all this space. So mid-span between columns. This is where in PT, the engineer can actually add some PT, additional PT, to self-support these cantilevers for the dead load and some live load from above. So this means all your formwork can be pulled out. This has been our office standard for years because it's easier for the contractor. Every formwork contractor wants you to do this because it precludes back shoring. All right, loads don't accumulate. And this is very common, more common in PT than in reinforced concrete. Because if this was into reinforced concrete, you would be back shoring both sides, not just one, as in a fifth span location. Again, reshores. You're simply just reshoring. You get to pull all your formwork and you just get to reshore. And when you have this condition, you just reshore 3 or 4 levels down so you can support the wet concrete for the floor that you're pouring. And then as you work your way up the building, you get to pull all your reshores when you don't need that floor to support that wet concrete. This system has been the most economical way to build things for the formwork and the concrete contractor. So PS0 stands for Pour Strip Zero. What we're doing is we're giving an alternate pour strip here. We're still allowing for movement, but we're just coupling rebar. On the left-hand side, we use a threaded technology that's been around for more than 30 years. And then on the right-hand side, we use a grouted technology that's been around in precast concrete for more than 50 years. First used in some of the highest seismic areas like California, Hawaii, Japan, things like that. And we're just a rebar slice, ICC approved, ACI code compliant, full tension splice, just splicing rebar. And you're looking down at our coupler. These are the portholes for grouting later that get used to lock the coupler up. So how do we stand up against a traditional pour strip? We're exactly like a traditional pour strip, except for the way we splice the rebar. And ACI allows 4 methods of splicing rebar. We're one of them. A mechanical splice is allowed by ACI. So is a lap splice. Those are the 2 primary ways engineers and contractors splice rebar: lap splice and mechanical splice. So full tension, yes, we got that. We don't have the leave out. We get all the good stuff with our system and none of the bad stuff. All right, we don't have the leave out. We don't have anything left in place, and we're safer. And we provide all the functionality and structural pieces that the engineer needs to transfer loads like a normal pour strip. Here we're going to show a little installation video, and it's just a couple minutes long, so just enjoy this. This is of our typical, not typical, but slab to slab install when you don't need a stressing strip, okay?
Introducing PS0, the pour strip alternative. PS0 is a unique, grouted rebar coupler that allows for concrete volume change while maintaining structural continuity. PS0 was developed by Gordon Rigstead, president of Rigstead Engineers, a 40-year-old structural engineering company specializing in concrete construction and repair. PS0 reduces traditional 4 to 8 foot wide pour strips to a grouted joint. It saves time and money without redesign, maintains structural rebar continuity, provides for safer construction, is ICC approved, and is made in the USA. PS0 mechanically couples rebar while allowing for movement caused by shrinkage and post-tensioning compression forces in the slab. Traditional pour strips require leave-out spaces and significant formwork. No leave-outs are needed with PS0. Let's take a look at the installation process. It starts with torquing a threaded rebar into the coupler. Next, a form placer is installed to the bulkhead and the coupler is placed onto the form placer and fastened to the bulkhead. Grout tubes are installed into the top of the coupler. These tubes create ports for grouting. Concrete is poured, and the grout tubes are cut off. Caps are installed so no debris gets into the coupler before grouting. Before the second pour, a bond breaker is sprayed onto the first pour. Then the continuation rebar is inserted into the coupler. The adjacent slab is poured directly up to the first pour. During the specified amount of time, the joint opens up as the concrete shrinks, without the need for traditional pour strip formwork. The couplers and joint are grouted, creating structural rebar continuity without significant reforming of the pour strip. PS0 saves time and money without redesign, maintains structural rebar continuity, provides for safer construction, is ICC approved, and is made in the USA. PS0, the pour strip alternative, developed by structural engineers.
So I hope you enjoyed that video. So again, that was of our typical application where you have a slab to slab, but you notice in that second slab pour, you have to have access to the outside of that second slab to stress if it's PT. So we have other applications. The first one is no stressing strip like we just saw. If you need a stressing strip, we're doing this commonly, but below grade, or if the contractor just wants to have a place to stress. In a wall area, we have a wall stressing strip with, we have a wall location with and without stressing strip, and construction sequencing. And we're going to go through these briefly. So in this first application, you just saw this. So we can go at a mid-span location, upper right. You see our couplers at the bottom. That's where the moment demand is high. And then lower right, you'll see that this is at that fifth point where the moment demand is low, and we just put the couplers at the mid depth of the slab where the shear, just because shear is the issue there. Okay. So if you need a stressing strip, both details on the right are the upper one is for at a mid span and the lower one is for at a fifth span. So if you can pour the right hand side first, and then you can stress, and you can pour the left-hand side first and stress, and then you can fill in the yellow immediately and pull your formwork in a day or two, just like you normally would when that gains some strength. And then you just reshore, simple, just reshore. And our continuation bar that goes in just laps with all the rebar in the slab already. So it's super simple for engineers, and you have all the ductility and everything you do in your normal pour strip. At a wall location, walls typically, concrete shrinks in two directions. So at a wall location, when we want to release the wall, we have a coupler that's slotted. As you can see here, we have a slot left to right, transverse, across the coupler. So this can be put in the wall without a stressing strip, upper right, or with a stressing strip. So, you can pour the red part. If you need the stressing strip, you could stress and then pour the yellow part. And this coupler will allow for that a wall to move. We're using these at shear walls, leave out places where normally the engineer doesn't want to lock the wall in right away, which causes a lot of issues later because they got to pour back these little strips. I mean, it's just fantastic. And they're just coming back later to grout our couplers. So again, construction sequencing. This is a lot like the first application where you're going slab to slab. But say the first sequence in blue goes up 20, 30 stories, and the second sequence is a small, 4, 5, 10, 8-story building, whatever. But the engineer wants to engage those lower levels to laterally support the whole system and hook the building together. So we can put our coupler in and then have the second sequence come up and allow for some longitudinal movement and transverse movement, and then they can be grouted later to have all the continuity you need. So we offer this, type 1 and type 2 for all you seismic folks out there. We have number 6s, number 7s, number 8s. Right now we have 6s ICC approved, and we're currently doing our testing, and we'll have ICC approval for number 7s and 8s. So if you're working in the seismic areas and using drag bars, or you're doing reinforced concrete and you have bigger bars in your beams, we can couple beam rebar too. We can always put equivalent number of 6s in. And that's what we do at a typical pour strip, because a lot of engineers use details from PTI that are like number 5s or 4s at like 12 or whatever inches on center, top and bottom. We're going to come in with a number 6 with a different spacing, and it works out great. We think that number 6 was like a sweet spot for slabs. So, and we have longitudinal movement and transverse with a slotted coupler. Here you go. We provide the coupler, the rebar, the threaded rebar, and the continuation rebar, the torque wrench, everything for a full install. And the BASF non-shrink grout for both the joint and our coupler. So it's very specific grout. We provide all that. We have engineering support. If your slab and your design is already done and you need some help just looking at how our system works with your slab, you can pass our model over to you. We can make it more economical. We can redesign it if we need to or want to work with you. And we'll take responsibility for that delegated design. We are experts in PT design, doing it over 40, 50 years old. So we can help with that. We also provide layout drawings, shop drawings. We're going to be on site for a pre-install meeting and for the install of the couplers and grouting, at least the first one, but it's super easy system, so it's easy to hang up. This is a hotel we did in Rochester, Minnesota, 4 levels of wood on 3 levels of PT. So On the left, you see some pour strips. On the right, you see our shop drawing. So this is the system, 3 levels of this, I think. And here we go. On the left-hand side, you see the first pour install with our couplers going in there, the threaded bars, and our grout tubes coming up. Our system looks a little different now. I'll show you some other pictures in a second. And on the right-hand side, you see our continuation rebar going in here. These are the continuation bar. System works, and this is at a mid-span location. You see our bars low, right? Our bars low. And this engineer, a lot of times at mid-span, we do not have a moment demand for up rebar at the top. So here we've removed all the top rebar, only the bottom, okay? So, and we can use shear keys if you like, and that can work with our system. So back. So this is what the finished product looks like. From above, on the left, this is your pour strip, and that's just your strip now. No big leave out, okay? And on the bottom, this is beautiful. Look at this. We have the ductwork, the plumbing, the wall system going in. All of this work right here would normally have to be delayed if it was a traditional pour strip. You can start to see the trickle-down effect with this. And a lot of podium work going around the country. We have 3 stories of wood up, and they framed over the pour strip. You can see that on the right. Not even grouted yet. So, and we're moving just a little bit, depending on the system. I mean, we're seeing, max that I've seen is maybe 5/8, ½ inch, but we're seeing things 1/4 inch. The slabs don't move that much, but if you don't allow for that movement, and your slab's gonna crack and have poor performance, okay? So this hospital we did down in Kansas City, 6-story, one-way reinforced concrete joist system. They were 2 months behind schedule. They're at a 5th span over here. So they required back shoring on this long span, column, long span on the right. These are our shop drawings on the right-hand side. And this is the first pour installation. On the left, we have our slab rebar, and on the right, we have the beam rebar. So we couple both the beams and the slabs here. And because we didn't have our number 8 approved yet, or our own independent testing, which we do first always, we had to replace 8s with 6s. So we're gonna couple the rebar at the end here, and you'll see that in a second. So on the left-hand side, this rebar that's sticking out right now, on the bottom, you can see the holes where the continuation bar is gonna go in. But these rebar that are sticking out, we have our couplers that are gonna get put on there, as you can see in the middle picture. So we always got a solution. This engineer was just giddy working with this. He loved it, saved so much time and effort. On the right-hand side, you see your continuation bar going in. Simple stuff, just lapping with a slab, other slab steel. This is your finished concrete, super easy. We're just finishing around. This is your joint. Look at all that. No safety issues, no nothing. And here, these next few pictures are awesome. This project had a traditional pour strip for the first 3 levels. We came in on level 4, and they were 2 months behind schedule because of some other issues. And they're telling us, GE Johnson there is telling us that they're going to open on schedule, and they gained all that back because of our pour strip solution and all of the other trades that are coming after. They didn't need back shoring, on this at all. Okay, for our system, you can just fly your forms normally. This is a bird's eye view from the crane, so you can see below on the lower side, that arrow, that's our pour strip right there. Upper side, you're seeing the open pour strip. And the leave out, I think 60 days or was this one, or 45, so something like that. But you're saving all that time. And the form work, you get to fly all your forms. Fly your forms right in. You can see all the formwork from bay to bay is now the same. And how do formwork contractors make money? Same repetition, repetition, repetition. Everybody knows repetition is very economical. This is a parking garage we had, a federal parking garage, 3-level PT. The lockable dowel was actually specified at this closure joint, which had the 5th point off the column, okay? They showed it. I think Kimley Horn was the engineer. They must have designed their lateral system to not transfer high tension loads in the diaphragm. It's not in a seismic area. So, if you're okay with epoxy being in your slab, the lockable dowel uses an epoxy grout that, if you have a fire rating, epoxy goes soft at like 150 to 200 degrees. So this is what their detail looked like. And again, these are dowels. It's like putting an expansion bolt in your slab, connecting your slab side to side. Look at it. Expansion bolt, that's smooth, okay? It's smooth. And it requires all this additional steel on both sides of the joint. Number 4 U-bars, 2 or 3 per, 2 or 3 each side, and all this longitudinal rebar. So if you see this, engineers, this is not a ductile solution to a pour strip, okay? A pour strip is ductile, lap splice. A mechanical splice is ductile. In my sketch on the right-hand side here, you can see, I just said, hey, we're gonna go 1 for 1. And we were less expensive. Plus they didn't need all that additional steel, which I told them, but they decided to put it in anyway because it was already bought. So they're torquing the bar here in the first installation. Simple mid depth of the slab installation here. And this is all that additional steel. So if you've seen the lockable dock, you've used it, if you're a contractor, look at all of this, okay? They're not little number 4s, but there's a ton of them. Look at this whole system on the right-hand side. You see all the way down. And that's both sides of the joint, okay? So our system was more economical here. They decided they already had all these rebar bought, so they left them in place, but you don't need all that rebar. Okay, this is all that rebar is needed because of Appendix D, now Chapter 17 for shear, not for anything transfer. We see cracks when these systems used that basically cracks where that shear bolt would do some kind of pullout. It's a non-ductile failure. And here they are finishing off the slab. Really simple. They cut our grout tubes off and plug them just like this. Okay, and now engineers will be able to measure, you know, what these joints are. This is a lateral system of a cantilever column, so it's probably more flexible, no shear walls. But this movement really depends on when things were stressed, what the stiffness and restraint is. It's hard for us. We can estimate what these movements are, but they're very difficult to calculate accurately. So now engineers are actually get to see, this is 1/4 inch right here, and it's a cantilever system. We're starting to keep data on what we see when we're on projects. It's pretty cool. So that's the end of the presentation. So again, PS0, we're the pour strip alternative because we still allow for that movement. You can find us on our website, pourstrip0.com, our phone number. Contact us, contact me. I'm, involved in ACI. So is my brother, 347. I sit on the new 319 code, which is for precast and ACI PCI code, voting member there. My dad is on the newly formed, I think last year, this productivity task group that's out there. And again, we're involved in both, ACI, PTI, we're engineers. We developed this system. We're not just sales guys. We're out running around giving, educational lunch and learns. We're talking with a lot of contractors, a lot of engineers. We're providing details now. We're being specified on projects right in the engineering drawings. And we're providing some alternate details. A lot of engineers are like, well, let me, put an alternate detail on my drawings. We can give you Revit files for those, and you can just put it as an alternate if you didn't want to force the contractor's hand, even though the solution is super simple. Our repeat customers basically the words are no brainer here, okay? It's no brainer. Once you look at all the costs in the system, and we're between $100 to $200 a lineal foot. And that's on par, if all the numbers are looked at appropriately, that's on par with what a traditional pour strip costs. So we're making sure the formwork, the concrete, the jet, everybody's making money here because the biggest benefit is for the general and schedule and the other trades. So generals out there, you need to look at the cost of your other contractors coming in and having to wait to do their work that they normally would have to wait on the normal pour strip. So now they can work seamlessly across the strip because there's no void there. So let us know if you have more interest. Again, like we're around and we're just out and about. I mean, COVID has kind of slowed everything down a little bit, but now things are speeding up. There's a lot of work going on. There's a lot of PT, a lot of reinforced concrete. We're working in North America everywhere right now. And Canada is looking like a big market for us with a lot of reinforced concrete up there and some hospitals we're doing. So we're out there doing this. Korea asked if they could republish our article, the Korean ACI. Rex Donaghy from ACI, if you know Rex, he contacted me, and their ACI in Korea wanted to publish our article. So we're working all over the place, and we think that over the next several years here, as we're getting this out there, pour strips, the leave out in pour strips is going to be a thing of the past, and engineers will no longer have to get those questions of why do we have these? Can we close them up sooner? Can we get rid of them? And on a number of projects now, and this is super common, everybody. So I go into these engineering offices, they have like an office standard of like 90-day leave out or a 120-day leave out. So tongue in cheek, knowingly, the contractor is going to come back and say, well, can we do it shorter? And so they're hoping to get 45 or 60 or 28, and but they're going on the they're starting out high and negotiating down, and they just know they get a hard time. So we're trying to make everybody's life easier. And we're engineers, we get those calls all the time. Now we're getting calls like, whoa, this is super easy. I one time through, and it gives continuity, gives everything structurally the engineer needs without all the headaches that give it, for the contractor. So I am going to make that a wrap. And thank you for your time. And I hope you enjoy the rest of the conference. And I hope to see you face to face sometime in the near future, and maybe even at the spring convention. Thank you again. Jared Rigsted, Vice President with PS0. Thank you.